Thank you for the introduction. So I will try to speak loudly. So yes, I'm Florent Gravin, and you can find me on the network. So I work at Camp to Camp, and we work a lot. We are a lot involved in OSGeo softwares, and in the couple of the last years, we invested a lot in research and development to catch the train of LLM and to see how we can leverage large language model in the geospatial ecosystem. So we mostly provide open source integration and open source softwares. So we try to work in this direction with the AI and the LLM as well. So I introduced the talk with this statement, which tells that almost 80% of AI project fails and only 30% of them goes beyond prototypes. So it means that lately there was a big hype around large language model, ChatGPT, and so on. And a lot of people try to jump in this niche. But actually, even though you can rapidly start to have something, playing with OpenAI API, for instance, it's very hard to fill the gap with production-ready services. And from this year of research and development and the product that we are developing in production, I will also give some feedback and return of experience about those kind of projects. So since last year, for instance, so I usually start talking about AI with this application. It's not the same keyboard, sorry. Switzerland. Okay. So the keyboard is not the real keyboard. Okay. So I don't know. It already works. So the idea behind talking to your maps means this kind of use case. So you expect that people, they can talk in natural language to a map or to a GIS software or to the data. And then the software magically with AI can answer to your needs. So this illustration shows that you can just talk in natural language and it's going to fetch OpenStreetMap data and display them on the map, and you can have a filter and so on. So this is very the first stage of the rocket. Just talk to the map and find the right data. Within all the process of data analysis, data usage, use case from maintainers, administrators, politicals, what is really important at first is to find the correct data set. And the talk is mostly about how to find the correct data set. Because when you found the correct data set, it's easier than to perform an analysis. But when you talk in natural language, it's not easy to know what you're talking about and how you can know what data set in your catalog, in the internet, you're going to use for your to answer your question. So large language models, it's like when you talk to GPT for the geospatial search and things around geospatial, what it can do, it can improve the search experience. So you can query natural language. You can have chatbot, GIS assistant within QGIS, within your web application. You can have a deeper analyzing system with location intelligence. So querying complex question to your territory and expect the system to answer where you should put a new highway, for instance. You can use it to enrich your data and your metadata. So if they are poor quality and you want just to have more information and more value from the data, you can enrich them from AI. And now you can also drive your GIS softwares with, for instance, MCP and reasoning you can do a lot with this model. So a quick recap about the search. So for instance, how we can improve the search. You know that usually a search in a catalog is a lexical search. So there is a perfect match on the word you type and the word which is used in the data or in the metadata. So the metadata is, for instance, the title or the description of the data. So if you generate synonyms, it will have a higher chance to match the query that you type or the words which are used in the description of the data. You can reformulate the user question. And the most used is the semantic search. So you can leverage LLMs or language model to vectorize text and then to perform Cartesian distance between the question and the dataset. So for instance, the semantic search, which is quite used to search the data, it's quite simple in appearance. It's a technology which rely on LLM to capture a text to a vector representation. So imagine you have a vector with 1,000 dimensions, for instance. One dimension could be, is it good or bad? Is it about a color? Is it so many different characteristics of what could be the meaning of something, and all the weight of all this dimension will give a representation of the meaning of the text. And with the meaning, we can understand what a dataset is talking about, because we are going to embed the description, the title, etc. And we will have a vector representation for all the datasets. And when a user enters a query, we will use the same language model to vectorize the query. And it means that all the document will be in this vector database with 1,000 of dimension, and the query will be there as well. And the two closest points, so it's mathematic. There is no AI involved in the distance computation. It will be hopefully the document that can answer the best to your question. So this video is so some questions are in French, but it's about population. On the left, you have a lexical search in Elasticsearch from GeoNetwork, and on the right, you have the semantic search. So if I say population, I have result on the left. But if I say demography evolution, I don't have any result on the left. Here it's water quality, and now is the water clean? And you see on the lexical search, I have nothing. So it's just to show how semantic, through the meaning, can answer way better to your question. So here it's a waste politic, and now when the garbage are collected, and you see the semantic understand what you want. So it finds the correct data set. In geospatial, to find a data, this is what I just mentioned before. You take the metadata, you embed them, and you compare with a semantic search to your question. And you have the similarity, which is the distance. So it helps you to know if it's good. So this is the very basic. But when you want a better system, you start to build a higher constellation of treatment and usage of LLM. So for instance, here when you have a user query, you can use LLM to extract within the query what the user is talking about. Does he want geospatial data? Does he want to find a data? Does he want to build a chart? Is he talking about a location? So for instance, I want to do a bike trip in Bosnia. We will extract that Bosnia is the location, bike trip is what the user wants, and then we will dispatch all this information to the system, and we will build a semantic search for bike tour, for instance, and we will perform an hybrid search with the location. We will fetch, for instance, the bounding box, and we will do an hybrid search. It means that it's both semantic and both lexical to find a better results. So you can build a very complex system, and in the end, we use again an LLM to say, okay, this was the original question at the beginning. Now the system has found 10 results. Can you give me which one you think is the best? So here there is several usage of the LLM. So we've built with Swiss Topo, we've built a prototype to showcase this thing. So I have here a demo as well. So here, show me hiking during the winter. Okay, and it is going to perform search, and you can see how it works. And there is you can see different system, different agent, and it was just done to compare and to see, is it effectively working, or is it just a fancy feature? So when you switch to the different agent, you see that when you do the hybrid search, so here I will request the hybrid search, which means that there is both semantic, both lexical search, and then we ask a re-ranking from the LLM, and the results, so you just have to believe me, are really close to answer the question I've asked here. So we just incrementally move forward with this structure. So this was a prototype, and now we are developing, and it's almost in production ready, a chatbot for a geospatial platform called GeoOrchestra, which embed a GeoNetwork, spatial catalogs, and Mapster for the spatial maps. And what are the risks, and what is the gap to go to production? The risk is that people have too big expectation. When they see ChatGPT, they think it's magic, and they can ask anything without understanding how it works and how we can effectively build a system that can really answer the question. Yes, then you have to really define the goals you want to achieve with LLM and AI in your system. Is it to find the data? Is it to make location intelligence, data visualization, analysis? The risk is also from the data quality. So if the data, you don't have good metadata, your system won't work effectively. Garbage in, garbage out. So it's very important to have good metadata, and even more when you use a language model. And then it's an expertise domain which moves very fast, and it's hard to catch up. So you really need to rely on people, on your own, on our external people who follow the trends, follow what's going on, etc. So the structure that I show you is called a retrieval augmented generation system. So it means that we use the LLM not for his knowledge, but for his ability to reason. The knowledge, you know that they have been trained on the internet, so they know everything that is on the internet. It's not why we use LLM. RAG means that you can, for instance, if I ask question about OpenStreetMap, ChatGPT can answer because he knows the specification of OpenStreetMap. But if I ask a question about my own data set, he won't be able to answer. So this is the purpose of a RAG. It means that we ingest all our data sets or our metadata in our own knowledge base. And then the request, during the request, we do a semantic search to find all the documents, all the data, the metadata that can answer to my question. We fetch them all, and then we copy what is interesting in the next prompt that we will send to the LLM. Like that, we have a big context, and we tell the LLM to answer to the original question only with the context that we gave to him, or to it, sorry. So it means, okay, OpenAI or Mistral, don't just answer my question with the document that I sent to you. So it will be able to answer the question to you on your data, and it won't use what it knows. So a good RAG application depends on a good search. And, oh, it's French. there are a lot of issue about the data, the availability, the quality, the governance, the format, the usability, etc. So you need, if you want to jump into that, you need to have a really good governance, policies, best practices. You have to have a great data warehouse so everything can work. Just some slide about the how to go further. Here we see that, for instance, to find a data set, we need to compare the description vector to the question vector, and we do a semantic search. But LLMs are very bad about the contextualization of what you're talking about. So for instance, in Swiss Topo, we say, I want to swim near Genève. And swim, the LLM doesn't know that I am a human and I want to swim in a swimming pool or in a lake. And he return results about all the biology, the fishes, all the marine ecosystems within the lake. So just the information and the description of the dataset is not enough to have something that works 80% of the cases. So here we need to bring information, and more context. And we can think about the next phase could be to generate knowledge graphs about your data, about the concepts, about your vocabulary. So you really fill the gap between the data and the knowledge you have on your territory. And this gives way better results. What is hard with LLM and what is mandatory to move from a prototype to a production-ready services is to monitor the evolution of the capacity and the accuracy of the system. So what is very important is to know to build a big data set. So you put the question and you put what the system is supposed to answer. So which data is supposed to find, for instance. And then you build evaluators to say, okay, this answer is 80% correct or 90% correct. And every time you change a little prompt in your RAG or you add a new module in your RAG, you can know if your system is going better or worse. And without that, you can just evaluate your system by your own feeling. Okay? So it means, oh, it looks to work. And another people will ask completely different questions. And for him, it won't work. So this is crucial, like in the code development, you need to have tests and to monitor every increment of your system if it behaves better or worse. And there is the user feedback with the sum up and down. And the question here goes within the system, within the tests, and you enrich your test suite every time there is a user feedback. And you can know that your system is going better on the long road. So you can monitor all the calls to the LLMs, all what the systems are doing, etc. So now a bit something more fancy, agentic AI. So I've just talked about semantic search, RAG, but what is very powerful today is the ability of the LLM to reason and to act. So it means you answer a question and the LLM will know what he can do. He will have tools and he will call some tools and loop until he can have your final answer. So for instance, the LLM cannot compute geospatial coordinates. It cannot generate code, or it can generate code, but it cannot generate a chart. And what he does when you go in ChatGPT, for instance, he writes some code and then he executes the code. So this is kind of a tool, okay? And a tool allow the LLM to do many things. So for instance, here I ask, what is the elevation of Wabern? And I give the LLM two tools. One tool to know to find the XY of a location, and one tool to know the elevation of a XY. And the LLM is able to reason and to know, okay, I have these tools, and I will call the first tools to know the XY of Vabern, and then I will call the second tools to know the elevation of Vabern. So this is called function calling tools, and it's really the technology that will make you able to bring a revolution within your GIS system. After finding the correct data set, you can bind the LLM reasoning system with any kind of your tools, such as QGIS. This is my last slide. So here, it's a QGIS project, and I have metro station on the right. I can't really see them. On the left, I say, I want to see better the metro stations. And here, the LLM is connected to MCP server of QGIS, which means that QGIS provide in a standard way all the tools that it belongs. So it tells the LLM, okay, I can list the layer, I can style the layer, I can change the layer opacity, etc. The LLM doesn't know QGIS, but he read the MCP server specification and he knows what QGIS can do. And with my question, he understands that in my project, I have a layer about the station. He understands that it can change the style, and it just changed the style alone. The second question, I say, okay, but I have several lines on the metro. The demo is on my laptop, but to make it what? I just say the second question was just okay, but I want to differentiate the lines, and it goes within the data set. He understood that there is a line attribute, and then he made a filter on the style on the line to display two colors for the two lines. So with this example, I show really the ability of LLMs to reason. And then if you build SDI and systems which are able to provide tools to LLM, then you will be able to drive anything you want from natural language. That's my conclusion. Thank you.